Hi everybody, let us go ahead and go over the 5-3 worksheet all about medians and altitudes, and of course the infamous orthocenter problems here at the end. They're not too bad, we just need to be careful when we do them. So starting with number 11, there's kind of three questions in this. Given the midpoints of a triangle, which 2 points of concurrency can you locate? I'm going to number these. This will be question number 1. Then it says, which point of concurrency can you locate if you only know the angle bisectors? That'll be question 2. And which 2 points of concurrency can you locate by drawing only perpendicular segments? So, number 1, given the midpoints of a triangle. Using the midpoints of a triangle, you could either create the perpendicular bisector from them, which would help you to find the circumcenter. So one could be circumcenter. Or you could connect those midpoints to the opposite points of the triangle, the opposite vertices of the triangle, which would create the medians, which come together at the centroid. So either of those would work. For question 2, which point of concurrency can you locate if you only know the angle bisectors? The angle bisectors all meet at the incenter. So you will find the incenter. And then finally, which 2 points of concurrency can you locate by drawing only perpendicular segments? Well, if you draw the perpendicular bisectors, you'll find the circumcenter. But if you draw the perpendicular lines that come from the vertices and reach the opposite side and hit that side perpendicularly, aka the altitudes, then you will find the orthocenter. There you go. Number 12, a student uses the following explanation to identify the triangle's point of concurrency. Explain the student's error. So they said, a perpendicular segment bisects each side of the triangle, which is true. This is the perpendicular bisector of each side. According to the concurrency of altitudes theorem, the segments are concurrent. The point of concurrency is the orthocenter. However, these are not altitudes. We know that they're not altitudes because they don't hit the opposite vertex. They just are the perpendicular bisectors. So they don't hit any of the vertices. The perpendicular bisectors meet at the circumcenter and not the orthocenter. So the perpendicular segments shown, let's write in here, the perpendicular segments shown are not altitudes. Instead, the point of concurrency shown is the orthocenter. The point of concurrency shown is the orthocenter. There you go. Number 15, identify whether each segment is an altitude, an angle bisector, a median, or a perpendicular bisector. So, let's take a look. Firstly, we've got segment BD. BD is created by the angle bisector. So if it's an angle bisector there, that's what we want to write. This is an angle bisector. Then we've got FJ. FJ comes from a vertex of the triangle, and it hits the opposite side of the triangle at its midpoint, divides it into 2 equal pieces. That makes it a median. CE. CE comes from a point on the triangle, and it creates a perpendicular with the opposite side of a triangle. We don't have any information about whether it's a bisector, but since it hits the vertex, we can call that an altitude. And finally, KL. KL makes a perpendicular bisector with this side, and it doesn't hit a vertex at all. The only kind of line that doesn't hit a vertex at all is the perpendicular bisector. So that is a perpendicular bisector. All right. Coming up here, it says, what is the value of KL? So this is created by medians, right? We're going from the opposite side to the midpoint right here, and that's happening in all the sides of this triangle. So P is the centroid. And one thing we know about the centroid is that it divides the median in a 2-to-1 ratio, okay? So it divides it where the part with two of those, I get like the two side of the 2-to-1 is from the vertex to the centroid. And then from the centroid to the opposite side, that's the one part of the 2-to-1. So if this is a 2-to-1 ratio, then that means that the PK segment is going to be half of 15, or 7.5. So then LK is going to be both of those added together. So LK is going to be 15 plus half of 15, or 7.5. And that's going to give us 22.5. So KL is going to be 22.5 units. There we go. Number 18, state whether the orthocenter of each triangle is inside or outside the triangle or on the triangle. Explain your reasoning. So this first triangle is a right triangle, and in a right triangle, the orthocenter is on the triangle. So we're going to say it's on because it's a right triangle. B, this triangle has 3 acute angles, which means the orthocenter is inside the triangle. So it's in because this is an acute triangle. Letter C, rather. Again, it's also an acute triangle, which means it's also inside. Acute triangle. And then D is an obtuse triangle. It's got an obtuse angle in it, which means the orthocenter is outside the triangle. Because it's an obtuse triangle. All right. Number 23, identify the segments and point in triangle ABC. The segment AD, this one comes from a vertex and it hits the opposite side and breaks it in half, so that's a median. We'll go 1, 2, 3 with these. So 1 is a median. Then the segment BE is what? Well, BE comes from a vertex and it hits the opposite side at a right angle, doesn't divide the opposite side in half. So that's an altitude. And 3, the point X is the blank of the triangle. The point X appears to be where this median hits this median. The medians intersect at the point called the centroid. So that one is the centroid. Number 20, a large triangular shaped table is supported by a single pole at the center of gravity. How far is vertex C from the center of gravity? Now remember, center of gravity is another name for the centroid. If we were to put our finger on one spot where this table could balance, it would balance on the centroid. And we know that the centroid divides our table into, it divides the median into 2 pieces. So let's draw some pieces in here from point C to the midpoint. So there's going to be like that. And this would be a 4 feet piece, and this would be a 4 feet piece. Notice how this triangular table is an isosceles triangle. And since it's an isosceles triangle and I have a bisector here, that bisector happens to be the perpendicular bisector. And since that bisector happens to be the perpendicular bisector, I have a right triangle with a side length of 4 and 5, right? We can remember our Pythagorean triples, or we can use 4 squared plus x squared equals 5 squared to find out that x equals 3. So this is 3 units long. But of course, the centroid divides the median into a 1:2 ratio. So if this whole thing is 3 units long, 2 units are going to be on the side closest to the vertex, and 1 unit is going to be on the side closest to the opposite side of the triangle, like this. So that 3 gets broken up in a 2:1 ratio. And when it says how far is vertex C from the center of gravity, that's going to be the 2 portion here. So we're going to say it's 2 feet from the center of gravity. There we go. Number 21. To support a triangular kite, Hannah attaches thin strips of wood from each vertex perpendicular to the opposite edge. She then attaches the kite's string at the point of concurrency. To calculate the point of concurrency, she determines the coordinates of each vertex on a coordinate plane. What are the coordinates where the wood strips cross? Round your answer to the nearest hundredth. All right, so when we have this, we are finding the orthocenter, right? Because we have these opposite vertices that are coming at a right angle, but not necessarily at the midpoint. So these are altitudes. So we want to find out where our altitudes connect. So the whole process for that, let's go ahead and use, let's see, I'm going to label these points. So I'm going to label these A, B, and C. All right. And when I label these A, B, and C, I am going to go ahead and find the equation of AB. And I'm going to go ahead and find the equation of AC. So these are my first two things. So I look at AB, and I first need to find the slope of AB so I can find the equation. The slope of AB is actually vertical. It's undefined because I go from 0, 0 to 0, 58. So the slope is undefined. And when an equation has a slope that's undefined, then we can say, all right, once I know that, then the slope of the line perpendicular to it has to be 0. So the slope of the altitude, which is what we want to find the equation for, is 0. So altitude slope would be the opposite reciprocal of undefined, which is 0. And then we have to take a look at a point on the altitude of this line, and that's 36, 44. So the point 36, 44 is on that line. And since it's a line with a slope of 0, it's a y equals a number line. Y equals, let me bring this down here and make it bigger. Y equals the y value here. So we can write y equals 44. So the altitude to AB has an equation of y equals 44. Let's find the equation of the altitude that hits line AC. Firstly, we need to find the slope of AC. So I'm going to take y2 minus y1 over x2 minus x1. So 44 minus 0 over 36 minus 0 gives us 44 over 36, which simplifies to 11 over 9. Okay? And so the altitude slope, the slope perpendicular to the slope of this line, is going to be the opposite reciprocal of 11/9. So altitude slope will be -9 over 11. So then we can go ahead and we can say, okay, I have this slope of -9 over 11. One of the points on the altitude is 0, 58. So we'll use that point 0, 58 and the slope of -9 over 11. And hey, look, this is another easy equation to make because this is the y-intercept of the line, right? This is where the y-intercept is. So I can make this equation in y equals mx plus b by writing y equals negative 9/11 x plus 58. Normally, I would have to find the not the opposite reciprocal, the slope-intercept form or the point-slope form first, but I don't have to find the point-slope form first in this case because I have enough information. So those are my two equations of this line and this line. After I find those, I need to find where these two equations meet each other. So I need to set 44 equal to negative 9/11 x plus 58. So let's do that. 44 equals negative 9/11 x plus 58. And I can go ahead and find the answer here. Maybe I'll clear out the fractions by multiplying everything by 11 because I'm just not a fan of seeing those fractions. So 44 times 11 is going to give me 484 equals negative 9x plus 58 times 11, which is going to be 638. So then I'll go ahead and subtract 638 from each side. And that's going to give me negative 154 equals negative 9x. Divide by negative 9. And I get 17.11 equals x. So 17.11 is the x coordinate of where my equations intersect. We'll go ahead and draw that, right? The x coordinate of the orthocenter. Then we've got to find the y coordinate of the orthocenter. I already know the y coordinate of the orthocenter because I already know that y equals 44. So every y coordinate of the altitude right here is going to be 44. So I know that the x coordinate is 17.11. Let's see, 17.11, comma, a y coordinate of 44. And that is the coordinate points for my orthocenter. No, not a rectangle? Let's try that again. Whatever. Close enough. So that'll be my answer. I'm just going to rewrite that. One of these days, right? There we go. 17.11, comma, 44. And there we go. Then let's do this again. Find the coordinates of the orthocenter of a triangle with vertices at each set of points on a coordinate plane. So let's name these points to talk about them. We'll call them A, B, and C. I noticed that one of my points is 0, 0. So I think it's probably going to be easiest to find the altitudes to AB and the altitude to AC, because in each of those cases, finding the first slope is going to be much easier. So first I need to find the slope of AB, right? So I'm going to do 4 minus 0, which is 4, over 8 minus 0, which is 8. That's 1/2. So the perpendicular to AB, right? We're finding the perpendicular to AB because we're finding its altitude, would be the perpendicular slope would be the opposite reciprocal, -2. And I'm also, when I'm finding the altitude to AB, I'm going to use point C, right? This is the biggest mistake people make. I don't want to use A or B. I want to use point C because that's the one I didn't use yet. So point C is 4, 22. So I'll go ahead and put this in point slope form. Y minus y1, 22, equals my slope of -2 times x minus x1, which is 4. So that's going to be y minus 22 equals -2x plus 8. So add 22 to each side. and I get y equals negative 2x plus 30. So that's my first equation, the equation of the altitude to AB. Then I need to find the equation of the altitude to AC, which involves me first finding the slope of AC. Since A is 0, 0, the slope is going to be 22, my y coordinate, over 4, my x coordinate. And that's going to give me, let's see, 5.5. I think, let me check. 5.5. So my slope is 5.5. And then I need the opposite reciprocal. So actually, instead of using the decimal right away, I'm going to definitely need to use the simplified fraction, which would be 11 over 2. So then the opposite reciprocal of that, or the perpendicular slope, is going to be negative 2 over 11. Okay? Negative 2 over 11 is going to be, as a decimal, negative 0.18. Okay, so then I need to find my other point, right? I'm finding the altitude to AC. The altitude that hits AC will come from point B, the other point, which is 8, 4. So then I've got to go ahead and I've got to find the equation using slope or point slope form. So y minus 4 equals negative 0.18 parentheses x minus 8. That's going to give me y minus 4 equals negative 0.18x plus 5.45. Kind of 5.44. We'll go either way. Doesn't really matter. It's really close. Add 4 to both sides. Y equals negative 0.18x plus 9.44. So then we will say this is the equation of our second altitude. And once we find the equations of those altitudes, we want to set them equal to one another because we want to find where they cross. So the next thing we've got to do is write negative 2x plus 30 equals negative 0.18x plus 9.44. And then we're going to solve this. So let's add 2x to each side. Gives me 30 equals 0.02x plus 9.44. Subtract 9.44 from each side. I get 21.56, I think. 30 minus 9.44, 20.56 rather. All right, equals 0.02x divided by 0.02. And I get 1,028. Why does that seem not correct? Oh, because I didn't. It did. Hold on. 2. Oh, because it's not 0.2. That's the problem. Hold on. This is what happens when I make videos. We're going to start here. So we'll rewrite this part. We've got negative 2x plus 30 equals negative 0.18x plus 9.44. Plus 2 is going to give me 1.82. So 30 equals 1.82. That's better. X plus 9.44. And then I'm going to subtract 9.44 from both sides, which gives me 20.56 equals 1.82x. And then I'm going to divide that gives me 11.29, which is also not the answer I have on my paper. What else did I do? See, this is the problem with these questions. 0.18 times 8. Ah, I'm all the way up here with my mistakes. Look at this. You get a first person view. This is 1.44 plus 4, which gives me 5.44, which makes this number not 9.44, but 5.44. And if I am taking 5.44 here, then I have to subtract 5.44 from both sides instead of 9.44. 30 minus 5.44 is actually 24.56. I hope you don't think that I never make mistakes, because I make a lot of mistakes and I just try and hide them from you. 24.56 divided by 1.82 is going to give us 13.5. So 13.5 is our x coordinate. Let me get that one in a box here so we can say, all right, that's true. And then we can find our y coordinate by plugging our x coordinate into one of our equations. So we've got y equals negative 2x plus 30. So negative 2 times our x value of 13.5 plus 30 is going to give us y equals negative 27 plus 30 gives us y equals 3. So our final answer is going to be the coordinate point of the orthocenter, which is going to be 13.5, comma 3. There we go. Perfect. And one more on here. A triangle with vertices at 3, 4, and 9, 17 has a centroid at 8, 16. What are the coordinates of the third vertex? Okay, and so when we go through and we find that out, one way to do this would be graphing. The coordinates of the third vertex would be D, 12, 27. All right. The other way to do this, by the way, if you're like, that was not an explanation, is to notice that out of these options, we need to make a triangle when you plot this on a graph where the centroid is inside of the triangle. The only coordinate point of a third vertex that would make the centroid land inside of the triangle is 12, 27. These other three, if we use them as the vertex, the centroid would be outside of the triangle. We know a centroid has to be inside of the triangle. This is the only point that would make that centroid inside of the triangle with the vertexes 3, 4, 9, 17, and 12, 27. And you'll notice that if you draw them on graph paper. So that is everything for this worksheet. I know it's kind of a lot, but I also know that you can do it. So if you've got any questions, make sure you ask me, and have a wonderful day.